All right, problem 11. The researchers described in exercise 9 also measured the body temperatures of a randomly selected group of adults. The data he selected are summarized below. So we got the count, the mean, the median, the mid-range, the standard deviation, the range, and the IQR. Okay. So then the question is, are the necessary conditions for a t-interval satisfied? Explain. Okay. Let's go through that. So the first condition, just turn this. Okay. So A, condition 1 is random. And this is a random sample. Okay. Okay. Second is independent. And that is each subject's body temp is independent. The third is the 10% condition, and 52 is less than 10% of all adults. And the last one is we wouldn't have success failure because we have quantitative data now, right? We don't have P and Q, so we got the normal distribution. Is the distribution normal enough to continue? So we look at this, and this has a nice symmetric distribution. So it's not skewed, so it looks like we're good to go. Okay? So the distribution is roughly unimodal and symmetric. Okay? Then in B we got to find a confidence interval. So a confidence interval equals x bar plus or minus t times s over the square root of n, which is our standard error. Okay? So x bar in this case, the mean is 98.285. Plus or minus, we got to find t. S is the standard deviation, that's 0.6824 over the square root of n. Well, n in this case is 52. Okay, so let's talk about finding this t. It's a 98% confidence interval. So we're going to draw a distribution. We're going to shade in the middle 98%. That means there's 2% left. So there's 1% here, and there's 1% here. So that means that this distribution must start at the 0.01 percentile, or the first percentile, and it ends at the 99th percentile. Okay, so I got to figure out what that is. So what am I going to do? I'm going to go to the calculator, and I'm going to do second distribution, inverse t, 99th percentile. And since our sample size is 52, there would be 51 degrees of freedom. And that's going to come out to 2.402. Okay, so let's multiply 2.402 times 0.6824 and divide that by the square root of 52. And that comes out to 0.227. So now I'm going to do 98.285 minus 0.227, and that's my lower bound. And then I'm going to change it to my plus, and that's my upper bound. So from 98.06 to like 98.51. Okay, so that's my interval. It's going to be 98.06 to 98.51. Okay, so that's the answer to question B. Explain the meaning of this interval. So we are 98% confident that the adult mean body temp is between 98.06 degrees Fahrenheit and 98.51 degrees Fahrenheit. Okay? So that's the interpretation. And then it explains what does 98% confidence mean. 98% confidence, what that means, 98% of all random samples of size 52 will produce intervals that contain the true mean body temperature of adults. Okay, so if we were to do 100 samples of 52 random samples, we'd expect about 98 of them to contain the true mean body temperature of all adults. That's what a 98%, that's what the general definition of a 98% confidence interval is. And then question E says 98.6 is commonly assumed to be normal. Did this data suggest otherwise? Well, 98.6 degrees is not in this interval. So 98.6 degrees is not in this interval. So it does not appear that that is the mean body temperature of all adults. So there's strong evidence, okay, that the mean body temperature of all adults is lower than 98.6 degrees because our entire interval is below 98.6 degrees. Okay?